Second translation or shifting property. This is the third property of Laplace transform. As you know, there are four properties of Laplace transform. First is linearity property. Second is first translation or shifting property. Third is second translation or shifting property. And fourth is the change of scale property. So today we will have to prove this third property of Laplace transform, that is second translation or shifting property. According to this property, if Fs is the Laplace transform of Ft, now introducing new function gt, and this gt is Ft minus a when t is greater than a, it is 0 when t is less than a. That is, there are two conditions. If the Laplace transform of Ft is Fs, number one, and second is new function gt is in such a way its value is Ft minus a for t is greater than a, it is 0 when t is less than a. In that case, this theorem states Laplace transform of new function gt will be equal to e raised to power minus as Fs. This we will have to prove. That is, there are two conditions. If Laplace transform of Ft is Fs and new function gt is in such a way its value is Ft minus a for t is greater than a, it is 0 when t is less than a. In that case, the Laplace transform of this function, there is a Laplace transform of gt, will be equal to e raised to power minus ax Fs. This we will have to prove. So proof of this property is in such a way. Let us calculate the Laplace transform of new function gt. According to fundamental formula, to calculate the Laplace transform of any function, it will be equal to 0 to infinite e raised to power minus st, and then write down the function that is gt dt is equal to this 0 is the lower limit and this infinite is the upper limit. This whole integration can be divided into the sum of two integrations. First integration will have the limits 0 to a, and second integration will have the limits from a to infinite. That is, this can be rewritten as 0 to a e raised to power minus st gt dt plus integration a to infinite e raised to power minus st gt dt. So this whole integration 0 to infinite can be subdivided into two parts. First will have the limits 0 to a, and second will have the limits from a to infinite. Now, this will be 0 to a e raised to power minus st, this is 0 dt, because the value of gt is 0 when t lies between 0 to a. Because in the starting I have already told you this gt will have two conditions. This gt will have the value Ft minus a for t is greater than a. It is 0 when t is less than a. So here t is less than a, that's why the value of gt will be 0 So it is 0. That's why this whole term will become 0 plus. This is a to infinite e raised to power minus st. In this case, the value of gt will be f t minus a and dt, because the value of gt will be ft minus a for t is greater than a. That's why in second term, the value of gt will have to put ft minus a. So first term is 0 and second term is a to infinite e raised to power minus st f t minus a and dt. Now let us put t minus a is equal to u. That's why dt will be equal to du. It is clear. When t is equal to a, the value of u will be a minus a is equal to 0. If t is equal to infinite, the value of u will be infinite minus a is equal to infinite. That's why when t is equal to a, the value of u is 0. When t is equal to infinite, the value of u will be infinite. Therefore, in this case, the value of L g t, that is Laplace transform gt, will become 0 to infinite, because when t is equal to a, u is 0. When t is equal to infinite, u is infinite. And then e raised to power minus s and then u plus a. fu du, because t minus a is u. That's why we will have this u plus a here and f u is here. This can be written as 0 to infinite e raised to power minus su e raised to power minus sa fu du. Again, this can be written as e raised to power minus as will come outside the integration side, and inside the integration sign 0 to infinite we will have e raised to power minus su fu du. This is nothing but it is equal to e raised to power minus as and fs. So that's why we have proved the Laplace transform of gt is e raised to power minus as fs. So it is crystal clear that from the second translation or shifting property, if there are two conditions. First condition is if Laplace transform of ft is fs and a new function gt has the value ft minus a for t is greater than a, it is 0 when t is less than a. In that case, the Laplace transform of this function, that is the Laplace transform of gt, will be equal to e raised to power minus as and fs. Thank you.